Okay, so we're going to talk about logarithms, and now a lot of people always get this question from students: what's a logarithm? Right, I hear it all the time. What's a logarithm? Like, I just don't get it. What is it? Now I'm going to show you two graphs, right? The blue graph would be what's called an exponential function, right? It's like an exponential growth, like we've been talking about last week. While the logarithm looks almost exactly the same, except for it starts here and it goes like that. So this is actually symmetric. This is actually symmetric over the y equals x. So the logarithm and the exponentials are actually inverses of one another. And eventually what we're going to find out is how to use the logarithm to solve equations, all right, that you have never solved before. But anyway, as far as today goes, we're just going to talk about the definition of a logarithm. Now the easiest way for me to tell you is that the logarithm is just another way of writing an exponent. All right, so when I see something like this, it's kind of hard for me. Log base 2 of 8 is equal to what? And I normally struggle with that. But this is the same thing as this. So 2 to the what power is 8? Let's see, 2 to the second is 4, 2 to the third is 8, right? So again, 2 to the third power is 8. Now, so therefore, if that's a 3 here, that power is actually the answer for the logarithmic form. So again, these two are exactly the same. They're just written in a different way. All right, so if I ask you, what is the log base 2 of 16? That's the same thing as me asking you, 2 to the what power is 16? All right, and maybe some of you don't know, but some of you do, but 2 to the fourth power is 16. All right, so that means that the answer for this one is 4. Now, the next one, do you remember the next one? 2 to the what power is 1? Right, anything to the 0 power, anything to the 0 power is 1, so this has to be a 0. Okay, now, the next one are a little bit more difficult. Let's see if you remember. 2 to the what power is 1 over 2? Anyone? Do you remember if you have what happens if you have a negative 1 here? What would happen? Flips it, right? So this is actually the answer. 2 to the negative 1 is 1/2, right? So this is like, if I flip it, right, I make that exponent positive. So that's the answer for that one. So this is negative 1. It's kind of weird, right? Now, in general, this one's the general form of it. So 2 to the x power, that power is always going to be the answer of that logarithm. Does that make sense?
So if it's like, does that have to be an n, or could it be any letter and it would be x?
It can
besides
it can be any letter.
Besides
E.
Like, you know,
Yeah. So E, yes. Don't use E. The E has a different meaning.
That's in pre-cal, right?
Yes. So we're not going to deal with that very much, but yeah. So for example, in the next one, so on the next here, they're just asking you to write this logarithms as an exponent. All right, that's actually very easy. The base of this logarithm, which is that 3, that's going to be the base of your exponent. Okay? And this right here, this 4, is going to be the power. So we have 3 to the power of 4, and that right there, this 81, is hopefully what that's equal to. And it's very easy to tell if you did it wrong, because you should be able to at least look at this and know that you're right. 3 to the fourth power is 81. Okay. Now for the next one, think about it. This base right here, log base 4, that becomes the base of your exponent. And you're basically switching those two. This is 4 to the first. That's the power, remember. And that's that. Okay. Yeah, that's literally how you do that. That's all you do. Simple as that. All right, now for the other way around, if you have an equation written as an exponent form, and then want you to write this as a logarithmic form, and that normally takes me a little bit more thinking, but it's the same process. This right here is the base of your logarithm now. So this is going to be log base 8. Okay. And that 64 and that 2 are going to switch places, right? So the 64 is going to end up here, and the 2 is going to end over here. Does that make sense? So again, the 64 and the 2 kind of switch places at that point. Okay, for this last one right here, then 5 to the 0 power is 1. So we have the log base 5. Remember, that's the base of your logarithm. And you're going to switch the 0 and the 1. So this is that right there. It's pretty simple, right? All right. So on the next few, they're asking you not to use a calculator. to solve it. Now, obviously, they're assuming that you know a lot of your exponents, and some of you kind of don't, some of you do. So I don't really mind if you use your calculator, like your iPhone calculator, for example, at most. I mean, this one, most of you, and by the way, before you get too far ahead of yourself, this logarithm here is not the same as what you're seeing in most of these. All right, so if you try to sort of cheat, I guess, for the lack of a better word, if you try to go and be like, okay, that's log, is just not going to be the same. This is actually a log base 10, which I'm not going to get into right now, but again, so I don't care even if you use this calculator if you can't figure it out. By the way, 13 to the what power is 169? You remember that? 13 squared, right? 13 times 13 is 169. So stuff like that you may need, you can use a calculator for that if you choose to. Now, the way you do this without a calculator is that you ask yourself, this is 5, this is the base of my exponent. You're asking yourself 5, and this is blank, right? So I don't really have anything to switch here with. So if I switch that, I have 5 to the what power is 25, which is, what power is that? 2. That's the power of 2, right? 5 squared is 25, so that's how you write the answer. That's it for that. Yep, the answer is just 2. So for example, in the next one, what do you think the answer to the second one is? 2. 4 to the what power is 16. Well, that's just the 2. Okay? That's the way you need to see it. And sometimes some of you are going to ask me a question before you even write it like this, because you're just going to be like, oh yeah, I get it, and you're going to move on really fast. This one's interesting. It's asking you 4 to the what power is equal to negative 16. Is there any power, if the base is positive, where you're going to make that negative?
Would it have to be a fraction?
No, if you make it a fraction, well, I'm actually going to get to the fraction part of it, but it's a trick question. You can't do it. It's a no solution, all right? So again, it's a trick question because no matter what I put here, right? 4 squared is 16, I know that. But I can make a negative, all right? So I cannot make a negative, so there's no solution, all right? And in general, any logarithm where you have a negative in here, any logarithm, that's never going to happen. Okay, so that's never going to happen on there.
So those are automatically no solution?
Yeah. All right, on problem number 4, again, a lot of people would ask me, well, how do I do this? All right, why don't you try to do this one for just a few seconds, so it shouldn't take you that long. It's kind of a little tricky, but not too much. And do it the way that I'm showing you. 10 to the what is equal to 10 to the third. Ten to the what power is equal to 10 to the third. It's almost a trick question, if you will. It's just a 3. I don't have to do anything. Does that make sense? So if you think about it in this manner, it gets easier. Now, on the next part, this is when things get a little bit more difficult, but hopefully not too much. It's the same thing. I'm asking you 3 to the what power is equal to 1/3. Okay? Be -1, right. So in general, I'm going to write this for maybe the people that don't quite maybe understand this. If the answer is a fraction, at least in terms of what we're doing for this first worksheet, then the exponent is negative. And remember, when I say exponent, I mean the power, right? The power is going to be negative. And now don't get that confused. Please don't get that confused. This one with the one we did on example number 3, all right? All of this is positive. All right, notice that on this one I do have a negative inside the logarithm, so they're different. They're not the same. All right, now for the next one, it's something that we don't normally use very much, or at least we haven't in this class. We have 9 to the what power is equal to 3. Anybody want to take just a wild guess on you're probably going to be wrong, but let's just see.
Yes. Would it be 1/3?
Close. 1/2. Okay? Now, here's the weird part for y'all that we haven't talked about it in a long time. Will you agree with me that the square root of 9 is 3, right? Remember that you can write any root as an exponent. So this would be 9 to the 1/2 power is equal to 3. And if you had one of those yellow calculators, you can actually make sure that that's true. So anytime you write a square root, you can actually write it as to the power of a half. So 81, if I were to ask you, 81 to the 1/2 power, well, this is the same thing as the square root of 81. What's the square root of 81? 9, right? Now if I ask you for the 64 to the 1/2 power, that's the same thing as the square root of 64. It's 8, right? So that's the same thing. So don't forget that. That's a useful one. So again, this right here is 1/2. Okay, so again, notice the pattern though. If this is smaller, not a fraction, this is just smaller, then think about square roots also. And cube roots. What do you think you write a cube root? 1/3. Fourth root, 1/4. Fifth root, 1/5. In terms of powers. Alright, this last one. So this last one is probably the hardest one you're going to see on the next worksheet of the homework, the one you're doing right now. But this is the way you need to think about it, right? So we have 16 to the what power is equal to 1/2. Now this one's a little bit hard, all right, because remember what I said, right? If you have a fraction, you have a negative exponent. So we kind of know that ahead of time, hopefully. But let's think about it this way. 16, instead of thinking about this, think about this. Now this is going to be some kind of root. Like it's going to be a square root or a cube root or a fourth root. So now you have to think 16 to the what power is 2. Think about what root would give you that. Yeah, the fourth one. You're doing that with your fingers, right? Now the fourth root of 16 is 2. And if that doesn't make sense, right, just think about it in your head. If you have 2 times 2 times 2 times 2, you get 16. So that's a way to think about it. So again, 16 to the 1/4 is equal to 2. Okay, assuming you can even make that jump. Now, if I know that to be true, do we all agree on that? If I know that to be true, but do I have a 2 here or do I have a 1/2? I have a 1/2, right? So just to make it into a 1/2, I'm just going to make that power negative. Because remember that 16 to the negative 1/4 would be the same thing as 1 over 16 to the 1/4, right? And what did we say that this? What did we say 16 to the 1/4 was? It's equal to 2. So this is equal to 1/2. So long story short, this right here is your answer. Did that make sense? You're not going to have a whole lot of those, but does that make sense how you want to think about that? All right. If you have a fraction, I know I have a negative exponent, but once I turn it into this. If this is smaller, that means I have some kind of root. It could be a square root, which is a 1/2 power. It could be a cube root, which is a 1/3 power. It could be a fourth root, which is a 1/4 power. Yes?
It's not for the whole thing?
One more time?
It's not for the last thing?
Oh, I'm actually going to do a couple of problems of the homework, if you don't mind. Is that okay? All right, so let's take a look at the homework, because this should be relatively quick. All right, so, Caden, wake up, bud. Okay, no, don't do that. Now on this part right here, I just want to show you how easy this is, all right? On this one, they're just asking you to rewrite this. So if I'm going to rewrite it, remember this right here is the base of my exponent, and then I'm going to switch the 27 and the 3. So this is going to be 3 to the 3rd power. It's 27. Those are easy to check, right? 3 to the 3rd power is 27. Okay, that checks out. If we do one more, like number 2, that'd be 6. That's the base of the exponent. And we're going to switch the 36 and the 2. 6 squared is 36, just like that. So that's what we're doing for the first 8. Because the first 8, that's all you're doing. On 9 through 16, now you're going to write this in logarithmic form, and it's the same idea. This 3 right here becomes the base of your logarithm. So this is log base 3. Notice that I'm writing this as a subscript 3, right? It's not like a normal size 3, I guess. And now you're going to switch the 243 and the 5. So the 243 goes here, and the 5 goes right there. Does that make sense? Yes, no, maybe? Okay. And even the ones that look strange, right? I had a student ask me last period, what does that mean? All right, so that symbol means approximately. So that means it's not an exact number, but that's all right. The system is the same. This becomes the base of my logarithm, so I have log base 9. And this is, I'm going to switch to 2/3 and that 4.327. Switching that. That's it. Just like that. Okay. Now let's take a look at the rest of them. So the rest of them they're asking you to do this with data calculator. All right, basically from 17 all the way to 32. This should be relatively quick though. So on a problem like 17, remember if you're looking at this is what we just finished doing. I'm asking you 5 to the what power is 25. That's a 2, right? That's all you're doing. And even the ones, for example, some of you are probably going to ask me, I'm not going to talk about this one right now, but you're going to ask me, how do I do this? Please write it like that, and then the answer becomes apparent. That becomes very easy to see. All right, this one right here. What's the answer for that one?
0, right?
0. Right, because 12 to the what power is 1. And we already talked about this several times, right? Anything to the 0 power except for 0 is equal to 1. Does that make sense? And again, if you look in the back, it's the same type of problems after that. And if you have questions, like for example, even if number 25 looks difficult, write it the way that I showed you. 4 to the what power is equal to 4 to the 5/5 over 6. Okay?